Hi there everybody, thanks for checking in to watch the video on the solutions to the Chapter 1 test practice. Okay, let's get started. The first group of problems were about finding the value of x, and the way you do that was writing an equation that actually matches what the truth is about the diagram. Okay, that's kind of a long, awkward way of saying it, but you have to write an equation each time and solve it for x. In the first problem, that's the triangle sum theorem. All the angles in a triangle add up to 180. So you can see the equation there. That's 23 plus 19 plus x equals 180 degrees. Solve that equation for x and you get your answer pretty easily there. All right. Next one, those two angles in that diagram are alternate interior angles, and I thought my work was a little sloppy, so I thought I'd start over. So in the first set, we write the equation of those two angles being equal to each other, and it's a pretty easy equation to solve. Let's see, what I do, I added or subtracted 2x from both sides, then I added 4 to both sides, and you get your answer 21 equals x. Next problem, those two angles are not alternate interior. Instead, they are same side interior angles. They're on the same side of the transversal. So same side interior angles are supplementary. Same side supplementary. Remember that. Alternate interior angles are equal, same side interior angles are supplementary. So you can see our equation there is the sum of those two angles added up to equal 180, 3x plus x plus 20. And you can see the steps we use there to solve that equation. Pause the video anytime you want to have a slower look at it, but I'm going to keep going. Next group of problems. The first one, also supplementary angles. Those two form a linear pair. They add up to 180 degrees. So plus 3x minus 10 plus 2x plus 30 equals 180. There's your equation. Make sure you see how we simplified the left side to get all our like terms together and proceeded from there. In the next equation, it's pretty quick. Those are two vertical angles. Vertical angles are always congruent, so that was an easy equation to set up and to solve. In the next one, you see corresponding angles there. This one has some unnecessary information here. The 38 degrees, you don't really care about that. You really only care about the 20x plus 2 and the 142. Those are the corresponding angles. And the equation to solve there works out pretty quickly. Just recognizing what is true about each diagram and writing the proper equation. Remember, in all of these angle pair problems, the angles are either equal to each other or they are supplementary. There's almost no other situation. Okay, let's move on to the next group of problems, which is about multiplying binomials. We'll walk through this pretty quickly. Remember to combine your like terms after you've multiplied all the different parts together. So that's how we get the negative x there, negative 6x and 5x. Same thing over here, negative 4 and negative 9 is negative 13. All right, down here, kind of a funny thing happened. The negative x and the positive x cancel each other out, so no more x's. X squared minus 1 is the final answer there. And last but not least, I used a box on this one, and you can see in the box, if you use that method, the diagonal boxes there add up to combine to the middle term. Okay, next little problem was on the back side. We talked about this a great deal in class. This is an isosceles triangle, and what's true about an isosceles triangle is that it has two congruent sides. So that should give you a little clue as to the equation you want to say. Those two sides are equal to each other. So we have a pretty simple equation to solve. Make sure you separate the x's on one side of the equation and the numbers on the other. And you'll get x equals 11 if you do all that stuff right. Well, that's not the end of the story in this case, because the final question is, how long is each of the two congruent sides? So you take that value that you got for for x, which is 11, and you plug it into the expression. So 3x plus 18 becomes 3 times 11 plus 18. 5x minus 4 becomes 5 times 11 minus 4. And you see that in both cases you get 51, which is good. That's what we want. Both sides are the same, or two sides are the same in an isosceles triangle. Let's do the next problem. You've got a couple of equations to solve there. One, important to kind of slow down for a second, make sure you get all the different parts on the distributive property. All right, so 3 times x plus 5 gives me 3x plus 15. And negative 2 times x minus 1 gives me negative 2x plus 2. So all of that stuff on the left side of the equation has to be kind of spelled out clearly before you gather like terms together. And 3x minus 2x is positive 1x. 15 and 2 is 17, of course. And then it's pretty easy to solve and get your answer that way. Just be really careful at the beginning that you don't make a silly mistake using the distributive property. Next equation, I didn't really like the way that one played out on the paper, so I'm starting over here. The equation is 2x over 9 equals 3. And what I'm going to suggest to you is a method that you can always use to solve an equation with a fraction in it, and that is to multiply everything in the equation by the denominator of the fraction. In this case, that's 9. So you're going to multiply both sides of the equation by 9. Well, what happens on the left side is that those 9s cancel each other out. All right, that was the whole point of multiplying by 9, so you could cancel out the denominator there. And so you're left with just 2x. And on the right side, 3 times 9 is 27. You have to multiply both sides by the same number. So 3 times 9, there you go, 27. And now the equation is pretty easy to get to the solution, 13 and a half. In number 5, you are identifying these polygons by their precise name. That's an isosceles right triangle because it's got 2 angles that are the same, and it's also got that 90-degree angle there. So that's an isosceles right triangle. You could also say right isosceles triangle. That'd be the same. The last diagram there has 2 parallel sides, all right? And it's got another pair of parallel sides. It has 2 pairs of parallel sides. That is the definition of a parallelogram, okay? So make sure that you see that. We don't talk about parallelograms that much, but they're very important and very common. It's a big group of polygons. Last group in here are these diamond problems. Product and sum. Product goes on top, sum goes on the bottom. And you've been doing these for a while. Probably don't need to say too much about these. They're a cool little problem. Next, and the last problem starts off with sorting a bunch of polygons into some Venn diagrams. You can see the answers there. Just to explain a little bit, a square does have at least 2, actually it's got all 4 angles are the same, and it has the opposite sides on a square are parallel. A square is a kind of parallelogram. Next, a regular hexagon, which I sort of drew okay there, but it's not that perfect, also has parallel sides. That may surprise you, but opposite sides in a regular hexagon are parallel to each other. And the word regular in regular hexagon means that all the sides are congruent and all the angles are congruent. So it does have at least 2 equal angles, and it does have at least 1 pair of parallel sides. So it goes in the middle. So does parallelogram. Parallelogram has 2 pairs of parallel sides, and on a parallelogram, the opposite angles in the corners, in the opposite corners, those are always congruent to each other. So those angles are the same, and those angles are the same. All right? So it has 2 equal angles as well. A scalene triangle. Scalene means that no sides are equal on the triangle, so that means it cannot have any equal angles, and a triangle never has a pair of parallel sides. But in this case, the scalene triangle doesn't even get to go in one of the circles. You have to put that one kind of on the outside. That's kind of important. Don't get that wrong. Don't just leave it blank when you see this on the test. There may be something that does not fit in either one of the circles. Be sure to write it so that I'm clear that you understand what's going on there and you didn't just forget to write it. Okay? So yeah, so the D goes on the outside there. And the last one, I'm sorry, it's not the last one. A rhombus is a kind of parallelogram with 4 congruent sides and 4 congruent and opposite pairs of angles are congruent on a rhombus also, just like a parallelogram. So that goes in the middle, just like a parallelogram. And last but not least, here we go, equilateral triangle. All sides are the same on an equilateral triangle, and all angles are the same also. So it goes there in that right-hand circle, but it does not have a pair of parallel sides. All right, I hope that was helpful. Hope it wasn't too long. Glad you checked in, and thanks for watching. Bye.